All right, today we're going to take a deep dive, an architectural tour of one of the most underrated yet incredibly complex parts of our body, the scapula. You probably know it as your shoulder blade, and let me tell you, it's not just some flat bone, it's a total masterpiece of engineering, and we're about to look at its blueprints. So here's our game plan for this tour. First, we'll get our bearings and figure out where the scapula is. Then, we'll learn how to read its map, its different surfaces. After that, we'll visit the most important landmarks, see how it works as this busy hub for your muscles, and then get this. We'll uncover the secret blueprint of how it's even built in the first place. But before we jump in, quick question for you. What do you think is the busiest intersection in your entire body? Now, your mind might go to your hip or your knee, but the answer is going to surprise you. What if I told you it's that flat, triangular bone chilling in your upper back? Let's start the tour and find out why. Okay, section 1, your amazing shoulder blade. Every great exploration starts with a map, right? So first things first, let's pinpoint exactly where the scapula fits into the body's overall blueprint. So what even is the scapula? Well, technically, it's a flat, triangular bone on the posterolateral aspect of the chest wall. But in plain English, it sits on the back and at the side of your rib cage. It almost feels like it's just gliding right over your ribs when you move your arm. And to give you a sense of its size, just picture it on your own back. It's actually pretty big. It usually stretches from your second rib all the way down to your seventh. That is a serious piece of anatomical real estate we're talking about. On to section 2, navigating the scapula. So before we start exploring all the cool landmarks on this bone, we need to know how to read the map. And the first question is, how can you tell if you're holding a left or a right scapula? Seriously, imagine you've just found one of these. How in the world would you know which side of the body it belongs to? It seems super tricky, but there's actually a really logical 4-step process that anatomists use to solve this puzzle every single time. And here's that process. It's kind of like a little logic puzzle. Step 1, find the glenoid cavity. That's the big socket where your arm bone fits. It always has to face outwards. Step 2, find the thickest border. That beefy edge always runs straight down from the socket. Step 3, feel the back surface. It's convex, it curves out, and you literally can't miss that big bony ridge called the spine. And finally, step 4, the front surface, the part that sits against your ribs, is concave, like it's scooped out. You follow those 4 rules and boom, you can orient any scapula perfectly. All right, section 3, exploring key landmarks. Now that we know our way around, it's time to visit the major junctions and highways on this incredible bone. Our first stop is a little feature called the suprascapular notch. And as you can see, it starts as just a small cutout in the bone. But what's so cool is that a ligament stretches right over the top of it, basically building a roof and turning that notch into a full-on tunnel, or what anatomists call a foramen. And what travels through there is absolutely critical. This little tunnel is the perfect example of a classic anatomy rule. You see, the suprascapular artery travels over the ligament, while the suprascapular nerve goes under it, right through the tunnel. There's a great mnemonic for this: Army over Navy, artery over nerve. And this isn't just a fun fact, it's hugely important for surgeons. Damaging that nerve could cause some serious problems with shoulder function. Okay, our next landmark is one you can actually feel on yourself right now. Go ahead, reach up to the very top of your shoulder. That bony point you feel, that's the acromion. It's the highest peak in this whole scapular landscape. And, as you're about to see, it's a super important anchor point. So this high point acts as a major anchor for some big-time players. You've got the massive trapezius muscle pulling on it from one side, while your main shoulder muscle, the deltoid, pulls from the other. It's like a constant game of bony tug-of-war. Plus, it anchors the coracoacromial ligament, which helps form the roof over the shoulder joint, giving it some much-needed stability. Section 4, a hub for your muscles. All this talk about attachments leads us perfectly into our next section, because the scapula isn't just a static piece of bone, not at all. It's a bustling hub, just swarming with muscles and ligaments that are pulling on it from all directions. Let's start with another huge junction, the coracoid process. This thing is so interesting. It's this hook-like part that juts out from the front of the scapula, and its name literally means like a crow's beak. And yeah, you can totally see why. But don't let its small size fool you. This little projection is an insanely busy anchor point. I mean, just look at how much stuff connects to this one spot. It's wild. You've got 3 different muscles attaching here. We're talking parts of your biceps and your pec minor. And if that wasn't enough, 3 major ligaments also anchor themselves right here to stabilize the whole shoulder. That's 6 different structures, all meeting at one tiny hook-like piece of bone. All right, next up on our tour, let's head over to the medial border. That's the long, straight edge of the scapula that's closest to your spine. You can think of this entire edge as a landing strip or a runway for a bunch of key muscles that stabilize and move your shoulder blade. So on the front side, you have the powerful serratus anterior, which is the muscle that helps you pull your shoulder blade forward, like when you're throwing a punch. Then, if you flip it over to the back, you've got 3 muscles stacked in a neat vertical line, the levator scapulae up top, and the rhomboid minor and major just below it. Those are the ones you use when you squeeze your shoulder blades together. It's just a beautifully organized system. And finally, let's zoom way in on 2 tiny but super important spots right next to that arm socket. Just above the socket, you have the supraglenoid tubercle, and that's the starting line for the long head of your biceps. And just below it, you've got the infraglenoid tubercle, which is the starting point for the long head of your triceps. It is just amazing to think that your 2 main arm muscles, biceps and triceps, both start their journey from these 2 tiny little bumps on your scapula. And that brings us to our final section, the scapula's secret blueprint. So after seeing how complex this oddly shaped bone is, with all its hooks and ridges and attachment points, you have to wonder, how does a structure like this even come to be? Well, the answer lies in one single number: 8. So what's so special about the number 8? Well, it means the scapula doesn't just grow from one solid piece of cartilage. No way. It actually develops from 8 separate ossification centers. Basically, distinct points where bone starts to form. Think of it like a really complex puzzle. All these individual bony pieces grow and then fuse together throughout your childhood and teenage years, finally creating the single intricate bone we have as adults. So, after this whole tour, what's the final verdict? You've got its unique shape, these critical tunnels for nerves and arteries, its job as a central hub for almost 20 different muscles, all built from 8 separate pieces that have to fuse together perfectly. Is the scapula just a simple bone, or is it a true masterpiece of biological engineering? I think we know the answer. Thanks for joining me on this deep dive.